Yeah.
So Daniel, from
Another controversial take.
let's go.
Why herd immunity is a useless statistic.
Ooh, I'm intrigued. Go for it.
If you've ever read the news about COVID, it seems like journalists are obsessed with the question, when are we going to reach herd immunity? And I think people are collectively asking this question because they believe that once we reach this magic threshold, we will be safe from COVID, or at least significantly safer from it than we were before. But I'm here to shatter that pipe dream because reaching herd immunity is nothing more than an arbitrary statistic used to standardize and normalize infection rate across populations. First, let me explain what herd immunity is. The idea is that as more people become immune to COVID as a result of either vaccination or contracting the disease already, the rate of transmission to non-immunized people will decrease. The reason for this is that the way we transmit contagious diseases is by coming into contact with other people. By the simple fact that more people are now immunized, a smaller proportion of the people we bump into are able to get sick from us. And so the rate of infection decreases as immunity increases. This is a pretty obvious view, right? However, many people think that this phenomenon occurs only at a certain threshold, where once a certain number of people become immune, we reach herd immunity. But before I explain why this is wrong, there's actually a very tempting reason for why you might believe in this false view. So let's think about the model of disease transmission. We have infected people, uninfected people, and immune people, right? Infected people can infect uninfected people. It's going to get kind of complicated, but infected people cannot infect immune people. And infected people eventually either die or recover to become immune. Now, if we plot the total number of infected people across time, so not total as in the cumulative number of infected people, but the amount of people we have right now across time, we will see a normal distribution, so like this kind of shape. And this is because initially we only have a few people who are infected, so infection rate is really slow, but exponentially increases as more people become infected, and they themselves become vectors of infection, so we have an increase. However, this exponential increase doesn't continue infinitely. This is because as the number of infected people increase, the number of immune people also increase, and the number of uninfected people decreases. So essentially, the amount of people who can infect others is always increasing, but the number of people who can be infected is also always decreasing too. And so there comes a point where the rate of transmission dips below the rate of recovery. And that's when the total number of infected people flatlines and begins to decrease. That's the peak of the normal distribution. So it is true that there is a point where the net infection rate goes below zero, which is at that point, as a result of the mechanisms of herd immunity. But this point isn't meaningful for you and I, because transmission rates are still above zero at that point, and it's changing at the same rate as it was before and after we reach the top of the normal curve. And so that's why I don't find it a useful metric for claiming that once we reach herd immunity, we're all safe, because that's not true. So what do you think?
I mean, there's some stuff that I don't understand. I know this because look at measles, right? Whenever there's a community that doesn't get vaccinated for measles, we see outbreaks for measles. And at least in France, I remember this because I was reading an article on Le Monde that there were that any time that the herd immunity rate or the vaccination rate for measles drops below 92%, there was a huge outbreak among school children. It was like either 92 or 94. I don't have the exact numbers in my head, but it's like when it falls to a certain threshold, there's an immediate outbreak at that time. I think there might be some validity to it for diseases that were like next to eradicated. Like, for example, we have herd immunity from smallpox and polio. We're not going to get smallpox and polio because everyone who has it has already died and we've been vaccinated everyone. I have not received a smallpox vaccine because I lived in a time after smallpox was eradicated. If smallpox comes back, I'm a dead man. So I wouldn't say that herd immunity is. I think herd immunity is very vague. I think the numbers are very hard to calculate. I think it changes for every disease, but I don't think it's a useless statistic.
I think, like I already said, herd immunity is a perfectly valid concept in itself, and that's actually the reason why it's even shaped like this and not just infinite. You know, so for example, the measles and the measles example you gave, it makes sense that like if everyone is vaccinated, or at least like almost everyone is vaccinated, then if someone gets measles, then it's very unlikely for other people to.
Yeah.
And if no one's vaccinated or very little people vaccinated, then measles will spread. That's pretty self-explanatory and it makes sense. But the point is that there's no actual threshold where once you cross it, then the transmission rate suddenly jumps or suddenly decreases. That's not the case. It's like gradual. And so it's not like you have to have 90.5% of people vaccinated.
I think it's very gradual if there is a community that doesn't, if there's a community that does not vaccinate, whether it's the Orthodox Jewish community or the Somali community in Minnesota, and immediately in that entire area there's a huge outbreak of measles. I feel like there's a very drastic on-off switch right there. I think getting to herd immunity, you have some validity in saying that there's not going to be like a certain number we reach and then everything is perfect. It's like things are going to be more perfect the closer we get to 100% vaccination.
Yeah, I know. Like, but that's not like reaching herd immunity. That's just herd immunity affecting us more and more proportional to how much we vaccinate.
Yeah, so I think herd immunity is the point where we can trust people to not spread the virus to us, and we can trust people not to spread smallpox to us because no one has smallpox. I don't know. I feel like your contention might not be with herd immunity, but the way that the discourse behind herd immunity, how we talk about it. I think you're more.
Yeah, that's
I think
actually like
you're more upset with how the media, journalists, reporters talk about herd immunity as some sort of magic number that solves all of our problems. Republican politicians too, rather than just the scientific concept itself.
Yeah, exactly. The scientific concept is just basically math.
Yeah. So I mean, if you remember what I said about misinformation, people are stupid. I mean, they're not going to talk about this in a responsible way. They're going to say stupid things about this, and I think that's just what triggered you.
And also the math of it is very interesting because you have to understand acceleration velocity. You have to understand rate and the rate of the rate.
Okay.
Because if the rate of transmission if the rate of the transmission doesn't change, so basically
if the rate of the rate doesn't change,
so the rate of the transmission is say let's say it's a 9% transmission rate for every person. So every person transmits the virus to one other person.
Yeah.
That's the rate of transmission. That basically describes how risky it is to get the vaccine. I mean, to get
the disease.
Yeah, to get the disease, right?
Vaccines are safe. Take them,
yes,
please.
That's the rate of transmission. That's the rate of transmission. The rate of transmission is how much it changes over time.
Yeah.
Right? So if that is constant across the number of people who get vaccinated, then it makes no sense to say that at a certain point there's a much better safety.
Possibly, but I don't think the rate of the rate ever stays constant.
I think it does here because it's like acceleration.
So how about this? I'll explain this in a way for the people who don't understand calculus to visualize this. You know logarithmic graphs? You don't need to know what a logarithm is. Just know those logarithmic graphs that you can see on COVID reports. If there's a straight line of logarithmic graph, that means it's a constant growth of, say, 9%. If the graph looks curvy, then that means there's a growth on top of growth. That it's going to be 9% one day, then 11%, then 13%, then 15%. It's growing on top of every growth. That is what Daniel's saying. I think for the most part, we don't see like straight growth. Mostly because we have changing conditions, the population size changes. If half the people are already infected, and they won't get it again, I think they're going to start seeing a negative growth in the rate of transmissions, and I think that's what's going to eventually lead to zero. The second difference,
Yeah, of course.
the second derivative is going to be negative.
Yeah.
So I think the moment the second derivative becomes negative, I think that's what we should consider herd immunity.
No, but
It's been a while since I've done calculus.
yeah, same. So the total infection rate, the total wait.
Daniel, why are you
Shit.
torturing me with math?
I think my point was there's no such thing as that switching to negative.
I mean, that has definitely happened. The fact is, there was one point where millions of people would get smallpox, and now there's no one with smallpox. That we eradicated smallpox. I mean, polio was, I think, back in 2016, eradicated in Pakistan, the last country that had polio. We eradicated it from the planet. That is nothing if not a negative second difference, or a negative second derivative. Us vaccinating people is quite literally a negative second derivative.
Okay, I think I know how to think about the math now. Let's talk about math. Come on, it's so interesting. No. So you have this curve. This is
gonna be my mom's favorite episode.
Number of this is the number of people in percent who have the disease, right? Who have COVID. It's like this, right, across time.
We can add a graph in post. You don't need to do that.
Okay, just like doing this. So at this point, at the peak of it, right? Okay. This is when the rate of infection goes negative, right?
Mm-hmm.
Or, well, the rate of transmission.
Yes.
Because obviously, infections are still happening. People are still contracting the virus. But the point is that so many people already have it that they're recovering at a faster rate than the people who are newly getting
it. So are we count? Because I was doing this all on like people who test positive for the first time. I'm not thinking about people who still have the disease. I think about like new positive test results.
Yeah. What about it?
So that's irrelevant if people get better or not, or if they die or not.
Well, if you're just considering the summation of all new people who get it, it's gonna be increasing for right until the disease is eradicated. Because no matter how many people heal or recover, as long as one new person gets the disease, then you add.
Wait. So, I'll push back again on that, because good containment policies in places like New Zealand saw that the first few people who got COVID just recovered from it and there were no cases there. I feel like New Zealand only had like a couple thousand COVID cases throughout the entire pandemic.
Mm-hmm. Okay.
So I feel like we can even make artificial herd immunity that way, by preventing it from spreading at all, by closing down your borders. I feel like herd immunity is real. I mean, scientists write a lot of papers on it. I feel like it is real. But that's a logical fallacy. That's deferring to authority.
Mm-hmm.
I'm not a biologist. I'm not an epidemiologist.
You're a data scientist. This is very data science, right?
Yeah, I guess, but there's not a lot of data here.
Well, it's like statistics.
There are not any numbers here. I don't think you... Wait, Daniel.
Theoretical.
Daniel, in your entire monologue, you have not given me a single number. The only number I have is a page number.
Well, this is theoretical. This is like math. I mean, statistics isn't just like finding data and analyzing.
So this is something...
Statistics is like also the math behind it. Which doesn't require data.
The math of statistics is so much less important than the actual methodology for how those numbers are gotten. The validity of the numbers gotten. Look, I actually explained this to a guy at Costco once, because he was very skeptical about why people should trust data. So I explained this to him. He basically said that, we have data for anything. If you look at any of the data, you can crunch them in any way, you can come to any conclusion. And I said, we make the mistake of getting the wrong types of data and creating bad models to get them. I'll give you a good example, right? Back in 2016, every poll predicted that Hillary Clinton was going to win by a landslide against Donald Trump. But she lost. The reason why she lost was because the polls were all looking at registered voters instead of likely voters. likely voters favor Trump. So based on the methodology of how people would answer to certain questions, we got different results. So even in polling data, if we don't have a good methodology, we can get results that are not accurate. Likewise, I don't know enough about what a good methodology looks like for epidemiology, so I can't qualify on this on the data science of this. But the math itself, Daniel, what you're saying is not wrong. I just don't think it takes into account everything, because you're looking at a population. So you're saying that at half the population infected,
Not half, but
around half, right?
no. This okay. Normal distribution is not what I actually mean by that. It's like a normally shaped curve where
Okay, so a bell curve, a bell curve.
Yeah, a bell curve across time.
Okay, so
where that's the total number of currently infected people.
Okay, so I looked at the bell curve as in terms of population, the percentage of population.
I should have explained that better.
Okay, then that makes so much more sense. Then yeah, obviously, if we're looking at over time, this model, the herd immunity model, doesn't make any sense, because the herd immunity doesn't take into context time. Time is irrelevant to herd immunity. What's relevant is the percentage of the population infected.
Across time, yeah.
No, not across time. Just the percentage of the population affected at all. At least regarding COVID-19.
Okay.
So if there's no one with COVID-19, there's no COVID-19 being spread. If everyone has COVID-19 recovered, we're at herd immunity where it can't spread between people.
Mm-hmm.
But that has to do with the number of people who are vaccinated or have recovered from the disease. That has nothing to do with like the timeline for when that happens. Because if you have something spread out as a timeline, you could have a situation where 1 million people were infected every day. We don't even have a rate. It's just 1 million people were infected every day. And then you could never reach herd immunity because you would need to wait 300 days for everyone to get there. You would have a completely different model for herd immunity. I flubbed up the explanation there. That one is on me. No, so but if we have like an arbitrary number of people, let's say we get like one person infected every day. There are 300 million people. We're never going to reach herd immunity, right?
What do you mean by herd immunity? That's my main point.
So herd immunity is the point where the disease is not going to spread like crazy. Spread like crazy means it becomes a situation where you can no longer contain it, right? If one person gets measles, you can lock them in a room, throw away the key, check back, give them a little bit of water, check back on them after a couple of weeks, measles gone. If we get to the point where just that one person existing, we can't lock them up in the room. They've already talked to 50 different people, and then they're not vaccinated, so it spreads, and the entire town has measles. That's different. So if herd immunity is the point where the outbreak of the disease can't be contained.
So what do you mean by contained? Like everyone who has COVID has to stay. If you're able to force everyone who has COVID to stay in their house,
if the disease doesn't become a rapidly spreading pandemic, where there's exponential growth, when there is not exponential growth, I think that I consider that herd immunity.
Okay, so you're saying so you actually agree that you actually agree with the journalist then, that once you reach the point where transmission rate, where the total number of infected people currently is not increasing, then that's herd immunity?
No, not if the total number of people infected is not increasing. I think it's at the point where there are next to zero new cases. I look at it in terms of new cases.
Okay, that would be literally that would be basically when the pandemic is over. That's basically the very end of the...
Wait, so herd immunity doesn't bring about the end of the pandemic. The end of the pandemic brings about herd immunity.
Then then I don't think you're referring to herd immunity in the same way that everyone else is. Because if herd immunity means there's next to no new cases, then that's basically when the pandemic's over and no one
maybe okay.
People refer to herd immunity as this. This is what I think. They refer to it as when you reach a point where
I need to search up
currently infected is
medical definition. I need the medical definition, because I do not trust myself. Herd immunity occurs when a large portion of the community becomes immune to the disease, making the spread of the disease from person to person unlikely. Okay, there's not.
Yeah, so basically just the argument that that's like slowing down. But what does it mean to reach herd?
Ask science. Okay, this could be good.
Herd immunity arises from the fact that if a large proportion of the population is vaccinated, then any individual who becomes infected is unlikely to come into contact with another unvaccinated person before they either succumb to or clear the infection. And therefore outbreaks don't happen because the infectious agent never has a chance to spread. And therefore the few unvaccinated individuals in the population are essentially immune.
Okay, so herd immunity means that even people who are not vaccinated are unlikely to get it.
Yeah, but the problem is like this is still like a tautology because it's just saying like when is the pandemic over?
I feel like that's okay. Wait, so then so I did have the correct definition per this person who has I had no credentials whatsoever.
Evolutionary theory and population genomics. That's basically that.
Do they have? I guess there's this random scientist on Reddit who claims to have a degree in evolutionary theory and genomics. Again, I don't know. Words are complicated. What I care about is the state where we don't have more dead people.
The pandemic.
Right. Let's get to the end of the pandemic.
Yeah,
Fuck herd immunity. Let's get to the end of the pandemic.
exactly. There's no magic number, bro. It's literally just continuous, smooth transition to the end of the pandemic.
Let's get
There's
100
no jump.
Let's
at
go
all.
110% vaccination. Let's go.
Yeah, exactly.
I got the Pfizer. I'll get the Moderna too, and I'll get the Johnson and Johnson.
Yeah.
I mean, the vaccines were terrible on me. I gained like 6 pounds from them, but I'll do it if it means fixing all of this and not having
If
to
I
do.
only gained 6 pounds from the vaccine, that would be nice.
Yeah, I gained 6 pounds of fat. Not nice.